This is the second part of the video for how to do the equation graphing practice booklet, and this part of the video will take you from page 15 to the very end of the booklet. Starting at page 15, it is a page without any actual graphs on it. Let's actually back a bit here. This is it right here. And all you have to do on this page is find the slope of each line. So if you don't know how to look at an equation that's in y equals mx plus b form and find the slope, you need to watch the previous videos. But if you are familiar with this form of an equation, you realize that the numerical coefficient on the x is the slope value. And remember that slope means rise over run. So I would say that my slope, which we usually symbolize with the letter m, is 2/3, which means that it would rise 2 for every 3 that it goes back and forth. So rise over run is 2/3. So I would say the slope is 2/3. And remember that as long as we're in this format, the number in front of x always is the slope. If you told me that the slope was 2/3 x, I'd mark you wrong because the x isn't actually part of the slope. 2, 1. Sorry for the interruption, and we're back. So yeah, 2/3 is the slope. When I look at one like this, remember that this number is a fraction to me, so I could say that the slope is 2, or I could say that the slope is 2/1. And when I have that one, of course, that's going to be a negative slope. Don't forget that that negative belongs to the 3, so the slope is, in fact, -3, or again, if you want, -3/1, which means that it's a downward trending line like that. Then after the first 4 questions on page 15, you hit a question like this, which asks you to find the slope. And if you tell me the slope is just the number in front of x, it's the 2, you'd in fact be wrong, because the equation isn't yet in the form y equals mx plus b. So your job is to use your algebra skills to change this equation into a form that looks like that. So I would start with 2x minus 3y equals 6, and I'm going to isolate for the variable y. And to do that, I'm going to minus 2x from both sides. Then I'm going to divide both sides of the equation by -3. Remember that both of these parts need to be divided by -3. And when you divide two negatives, you get a positive. So this number is 2/3 x, and this number is -2. So once again, my slope is 2/3. Here's another one like that. That's not yet in the right format. So I'm going to start by minusing x from both sides. And that's the only step I have to do. And don't forget, there is a number in front of that x. It's -1. So my slope would be -1. Or again, if you like, -1/1. This one again, I'm going to have to isolate for y. So I'm going to minus 3x from both sides. Then I'm going to divide each part of my equation by -4, which cancels the negative on that term and makes this term a -2. And all it's asking for is the slope, which is 3/4. So that's how you do page 15. And then from page 16 to the end, you have to graph equations that are in this not y equals mx plus b form. So let's just do the ones that we just did as examples. Once again, I can change that to y equals mx plus b. So when I did that, just having a quick review, that goes like this on my first step, and this on my second step. So my y-intercept is -2. And then I would go up 2 and over 3. And there's my line. That's way off. I'm actually going to undo that. That offends my eyes. There we go. Up 2 and over 3. And I'll actually use a line drawer for this. There we go. That's a little better. Perfect. Now, please remember that there is yet another way to do this, to graph from an equation like this, and we'll do that in a minute. But again, let's just finish those 2 other examples. Change that around, and you get y equals -x plus 5. So I start at 1, 2, 3, 4, 5, and I go down 1/1. So down 1/1, down 1/1, and again with my fancy line drawer. There we go. You should probably put arrows at the ends of all these lines, just to show that, you know, they go on forever. And for this one, again, my steps look like this. So y is equal to 3/4 x minus 2. So I'd start at -2, and I would go up 3/4. So up 3/1, 2, 3, 4 would be to this point here. And again, get my line drawer out and And it's off a little bit. That'll do. And there's my 3 examples. Now, like I said a second ago, there is a second way to do this. That's the way you did it in grade 8, where you make a table of values. Now, in grade 8, you probably did these, and there's, I think, a couple in the grade 9 textbook where it says go from -2 all the way to 2. I don't need 5 points to graph a straight line. 2 is going to do it, and I always encourage grade 9 students to think about it analytically. The easiest points to find here in this particular equation, since 2 and 3 are both factors of 6, would be to find the 2 places where it hits the axes. When x is 0, do a little bit of arithmetic here and some substitution. 2 times 0 minus 3y has to equal 6. So 2 times 0 is 0. So I have the equation -3y equals 6, which means y would be -2. So this would be -2. By the same logic, if y is 0, I'd have the equation 2x minus 3 times 0 equals 6. 3 times 0 is 0, so 2x equals 6, so x equals 3, and that's good enough. There's 2 easy points to graph. 0 over 2 down, check, and 3 over none up, check, and something like that. This one is even easier. Pretty easy to tell that when x is 0, y must be 5, and when y is 0, x must be 5. So I'd go 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5. And graph those with a line. Beautiful. This one presents a bit more of a challenge because while on the one hand, it would be easy to do for x is 0, because again, 3 times 0 minus 4y equals x, so -4y equals x, so y is equal to -2. No problems. But I don't think I would choose y equals 0. How come? Well, take a look. If I have a 0 in this number here, then I'm going to end up with 3x equals 8, and good luck graphing an x-coordinate of 2.6 repeating. I'd rather avoid that. So instead of 0, I'm going to try to find a point that logically won't give me a fraction or a decimal when I plug it into the x value. Now here's the way I reason this out. Since I know that when I plug in an x value here, I'm going to be moving this to the other side of the equation to combine with 8. Then I'm going to be dividing by 4. All I need to realize is that whatever this 8 and this number here add to has to be divisible by 4. Well, 8's already divisible by 4. So basically, if x is any multiple of 4, I'll still have a number divisible by 4 when I combine it with this number that's divisible by 4. So I'll let x be 4. So if x is 4, I get 12 minus 4y equals 8, which means -4y equals -4, which means y equals 1. And that's, again, 2 nice, easy points to graph. 0 over 2 down, and 4 over 1, 4 over and 1 up. And if you check back on the previous pages, these are the same exact lines we got the first time. So that's how to do the last 5 pages of that booklet. Good luck and have fun.